Welcome back. This is Richard Kuyava, Professor of Geography and member of the Social Dimensions team of the Building Resilience to Extreme Events project, which is part of Vermont EPSCoR and funded by the National Science Foundation. Welcome back to a series of videos which are exploring the use of the Clean Water Roadmap tools provided by the Vermont Department of Environmental Conservation. In the last video, we had been looking at the information on total phosphorus disaggregated by land use and land cover at the scale of the HUC-12 basins. And I want to, at the very beginning of this, before we turn to some scenario work, I just want to be clear that the downscaling of the SWOT model goes all the way down to the National Hydrography database plus catchment area. And so in the left-hand window here, where we're visualizing basin results, we're actually going to go to the NHD-Plus scale. It'll take a second. And you'll notice that the map gets redrawn at an even finer scale. And in exactly the same way, that we did for the HUC-12 basins, we can click on a particular NHD-Plus catchment. I'm going to click on this one. This is an unnamed catchment, but let's go down into the bottom panel as we've done earlier. And what this does is it tells you the hierarchy of catchment / watershed. So it's an unnamed catchment in the Pike River Basin, in the Missisquoi Tactical Basin. And here, the water quality blueprint variables are not calculated, but you got, oh, I beg your pardon, yes they are. Excuse me. We have the total phosphorus load, mean yield, the area of this catchment, and then here are those water quality blueprint indices, and then we have a percentage rank, and so this particular catchment is in the 24th percentile in terms of the Missisquoi Tactical Basin, and the 28th percentile, and that's in terms of total phosphorus load. We got the same pie chart here. Well, it's not the same, but it's the same kind of pie chart. And again, if we click on any of the slices, we end up getting into the disaggregated information for each of the land use or land cover types. And you can see that what we're seeing here is what actually happens for each one. And I don't want to spend a ton of time on this because it's exactly a repeat of the other things. But remember, if you want the pie chart, you can export it right here. So, just so that we can see this happen on screen, if you do click on another catchment, on the fly, the pie charts below are actually redrawn. And all of those data are recalculated. And that's what's kind of cool about this tool. I hope that makes sense to everybody. I was a little quick in moving past that particular phenomenon in the previous video, but that happens on the fly. And so if we go back to the HUC 12, exactly the same thing happens. You need a little bit more real estate here. Exactly the same thing happens as we click on different HUC 12 basins. And it's pretty important to understand that that's what's actually happening. Let me go back to the NHD-Plus, right? And we'll click on one. Let's actually minimize that for a minute. Let's zoom out and pick somewhere familiar. I'm going to reduce the opacity so that I can actually pick out Lake Carmi and put it and zoom right in on that particular region. Okay. And so if we look at Lake Carmi, let's let it reload, we can see here that around Lake Carmi things are, let's just take a look at the legend so we can see it. Let's make the opacity 100, hit the legend. You can see that around Lake Carmi, the kilograms of phosphorus in hectares per year, the yield is really high, with one exception of this little catchment. And so what I'm actually going to do is I'm actually going to click on that, and that's Marsh Brook. So what I want to do is, if we just move the map up slightly, I just want you to look with me at what happens when we go from Marsh Brook. Take a look at these pie charts. Marsh Brook is heavily forested, 70% forested for that particular catchment. And then we're just going to go to the next catchment. That's not a named catchment, but you can see what actually happens. You can see what actually happens when we go into that catchment. It is in the 76th percentile of total phosphorus load for the basin. That's comparing all other catchments at this scale. And so you can see how, it's a little bit of a blunt instrument, but you can see how we can research individual catchments at this scale. Many of these NHD plus catchments are unnamed, right? So we have to sort of be careful in terms of geography. But hopefully you're getting the idea of how that actually works. Okay, I'm going to carry on and we're going to change gears here. We're actually going to shift gears here, and we're going to be changing scale, but we're also going to explore the scenario tool. So what we're going to do here is we're going to rescale back up to the tactical basin level, and I'm going to press home, and I'm actually going to hide the catchment baseline summary, and this is familiar territory here. I'll zoom in a little bit. We're looking at total phosphorus yield. We're looking at all land types for the tactical basin. Our color scheme is green to red. Our legend is here. Opacity set at 100. There's that information screen. Just getting you back oriented very quickly. So now we're going to look at scenarios. Currently, DEC has a single scenario, and I've already mentioned this, but let me mention it again. It's the TMDL. It's the TMDL reasonable assurance scenario. That's important because it's a single scenario, which is the legal agreement that the state of Vermont signed with the EPA. Let's go into scenario mode, and here we have some information splash screens. So scenarios on this list have been developed and published by DEC planners? Well, for the public use at the moment, there's only one scenario. It's the RA, or reasonable assurance scenario. We're going to pick it. And so what it says is, it's the TMDL reasonable assurance scenario. It was created in October of last year. So because we were testing this platform, it was last revised in January of this year. And now we're in scenario mode. And so let me collapse that. What changes? Well, we now have 2 additional choices on the map type menu. When we were in baseline mode, we had baseline. If we choose scenario, the map is going to refresh. And it all went green. It all went green. And the reason it all went green is because the idea is at the tactical basin scale that phosphorus yield will be reduced. If we go to phosphorus load, you can see there are some differences. Right? You can see that there are some differences. The tactical basin scale is not that useful for looking at this. So we're actually going to go to the Huck 12 scale. And now we've got some color changes and we've got some information being given. And I'm going to keep it at that scale for the moment. And notice it's green to red, and it's worthwhile checking the legend. This is total phosphorus, and it's using what's called, I forgot to mention this earlier, it's called a quantile approach. And so it's basically setting up 5 categories and arranging the differences between the categories so that 20% of the observations are in each category. I think that's how they have this set up. I'm not absolutely positive, but it is 5 categories. So we know what's happening here now. Okay, we know that red is these are the yields that are agreed upon under the reasonable assurance scenario. This is at the Huck 12 scale, so it's been downscaled. And let's just turn it to yield, because those are total phosphorus numbers. And you can see, let's just look at the legend. You can see the yields. The geography of yields is not the same as the geography of load. And so we are looking at a whole bunch of areas where yield is going to be in the green. It's going to be very low. Now, watch this for just a second, because I'm going to switch it to the baseline scenario. Same scale. And you can see in the baseline scenario that there's a lot more red and orange than there is green. Here's the reasonable assurance scenario that has been agreed. So you can see dramatically at this scale the difference. Now, if we, and this is for all land types, and this is for total phosphorus yield, we also have the ability to map the reduction, and it should happen here. It should redraw. There we go. This is the reduction that they're expecting under the reasonable assurance phenomenon. Let's check the legend. And so this is the amount of phosphorus per hectare per year that is being reduced in terms of the yield. Right? Same idea. And I don't need to get into all of the details here, because remember, you can download all the data in tabular form. You can look at the pie charts, which we will do in a minute. If we look at total phosphorus reductions, okay, and we're looking at the Huck 12, these are the reductions in kilograms of phosphorus per year that are being called for. And you can see the largest reductions are those in red. And so you can see they're up here in the Missisquoi Basin, some of them in the Otter Creek Basin down here. So you sort of get the idea of the geography of this. I'm going to go back to the scenario mode for a second. I'm going to go back to the scenario mode for a second. And I'm actually going to look at the NHD-Plus scale. I'm going to go to the NHD-Plus scale. Right? And if we drop down here, we're looking at total phosphorus. So let's look at the yield. It's got to reload and it's a lot of polygons. You can see at that scale there's a ton of green, but it's not all dark green. And so disaggregation leads to different kinds of visions. So we could do this at any scale, and I think it's a good idea for you to explore for yourself at different scales. But let's just zoom in. Let's just zoom in to this northwestern corner up by the Canadian border. And let's just click on, that's a no-name catchment. Let's go over right by the lake somewhere. Still a no-name catchment. It's okay. This has 4 little screens associated with it, so let's look at what they are. Oh, this is actually paging us around. So there are some things in the way this this operates that I'm not even used to. I didn't know that that paged us around there, which is fine. So I'm going to bring up the dashboard, and I want to click on a catchment. I'm going to click on that one. It's Hungerford Brook. It's Hungerford Brook. And this is showing us the baseline summary. And I just want to check. I was going to do this live. Change this to baseline. I just want to see what happens here. We're still in Hungerford Brook. And so the table stays the same for the baseline scenario. I'm going to give us a little bit more real estate. We know we're looking at Hungerford Brook here in the NHD+. And we know we've got the pie charts here. And I'm actually going to click on cropland. And now we get to see what the scenario is asking for in terms of total phosphorus loading. And that's what's powerful about going into scenario mode. Because look, it's telling us that for cropland, for this Hungerford Brook catchment, the reasonable assurance is that there will be an 88% reduction. An 88% reduction in total phosphorus as part of the TMDL. You can see that for developed land, and I'll click on that, they're looking at a 90% reduction. These are the baseline pies. This is what it will look like. This is what it will look like under the scenario. And so the thing is here that we have the NHD+, we have the HUC12 catchments and basins. And so we have a way in the tool of looking at what the state of Vermont has agreed to. It's downscaled from the model, but what the state of Vermont has agreed to. And so check again, this is for Hungerford Brook, which is also Hungerford Brook in the HUC12 basin, and it's in the Missisquoi Tactical Basin. Look at the baseline pi. A lot of this is medium density development. That's 63.8% of the developed land is in medium density. Look at the scenario. Baseline scenario. Let's try cropland. Baseline scenario, and you can see the pie changes. I'm not that thrilled that the orientation of the pie has shifted. Not much I can do about that, but you can see that the pie, the area of the pie changes, and they're looking for an 88% reduction in total phosphorus. What's the comparison? Well, here's the baseline. Here's the baseline. I'm not sure what the acronyms here mean, but this is the scenario. I might be able to figure out the corn, hay, non-clay. So let's go back here. Corn, hay, non-clay. So these are just acronyms of the various land use land covers under the cropland disaggregation. Makes sense? And so here we are now here we are in the baseline model. Here we are with the reasonable assurance model, and that's an 88% reduction. Excuse me. Let me take that back. That's an 88% reduction for cropland. Let's click on the BMPs, and we're getting a little bit more information. We're getting a little bit more information, not just in terms of what's happening, but the extent to which the BMPs have actually been applied. Now, I don't know whether this will do it on the fly. Let's try. If we switch back to baseline, not sure what will happen. We may have to. Let's have a look. So it's still holding the scenario because we're in scenario mode. So once you go into scenario mode, the pie charts are displaying the scenarios. But we're actually getting, let's read it carefully, the following BMPs have been applied to the selective land use cover for the current scenario and basin. This is the percentage of coverage. And so I think what we're seeing here is a tremendous improvement in terms of the amount of information that's being delivered. Based on the SWOT model and the reasonable assurance TMDL scenario. And so, again, remember, this is clickable. And so if we close up Hungerford Brook and we go, let's zoom in a little bit, and we look at, we'll go out of the northwest, and we look here. This is Potash Brook, which is a part of Potash Brook is impaired, but we're just looking at phosphorus here. And if we go down below into the dashboard, and we look at the pie chart here, we're looking at the developed land is what's really driving the phosphorus load here. Let's click on it. What are they talking about? Well, they're talking about, for this catchment, this NHD-Plus catchment, a 49% reduction in phosphorus, and for developed land, they want a 55.8% reduction. Let's look. There's the baseline pie. That's the scenario. Here's the comparison. And these are the BMPs, including a ban on phosphorus fertilizer use, surface infiltration practices, some wet pond and constructed wetlands. And so we're getting BMPs here that are tailored, as we saw before, but now they have numbers on them. So you can see for this basin, catch basin cleaning is going to reduce some sediment and phosphorus. They're going to sweep the roads twice a year. They're going to improve surface infiltration practices. And you get a sense there's some cropland in this catchment. You can see there's some change in crop rotation. There's some conservation tillage. There's some manure injection and a conversion to hay instead of corn, I would guess. And so what we're seeing here then is we're seeing actual information and on the fly ability to compare the baseline data that the SWOT model produces at different geographical scales with the reasonable assurance scenario that the state of Vermont has agreed with EPA to improve the water quality in Lake Champlain by reducing the total maximum daily load of phosphorus in different lake segments, with the model here downscaling those targets for specific catchment areas and giving undergraduates, interns, graduate students, public policy officials, and the public a way of seeing the way in which the Department of Environmental Conservation is trying to move the ball forward here. And this is Richard Cuyaba. Thanks for watching.